Hi everyone, this is Sharan here. Welcome to my channel. Today we are going to start with visualization using Python. Over the next 3 days, we will be starting from the scratch and we will be covering all the important concepts and techniques that is required to learn from the visualization point of view. So for the day one, we will be starting with the Matplot library. We will start with how to plot a simple line chart and how to provide a name to the axis as well as giving the title to a chart, and we will be moving on to plotting a trend chart with multiple trends, and we will be going through the scatter plot and as well as coming up with the dual axis in a plot. On the second day, we will be going into the details of other charts on the Matplot library, and finally we will end with the Seaborn library as well as making some interactive charts. So before we get into the details, so the difference between the Matplot library as well as Seaborn is the Matplot library it does require some lines of code, more than few, and it is highly customizable. Like whatever you want to do to a particular chart, you should be able to customize it as per your requirement. On the other hand, the Seaborn is kind of a boiler template. Like it comes with a default template which is really good, attractive. It doesn't allow, Seaborn package doesn't allow much of a customization, but it is really good for doing a quick and dirty analysis. So with just one line of code, you should be able to plot multiple charts, and it usually doesn't require any formatting to the data. The raw data can as such be used in order to make all the plots. And finally, we will be using, we will be going through one package which can be used to build an interactive charts. So interactive charts, because if we want to get, or if we want to look into the details, granular details, zoom into the trend that is present in a particular chart, so then interactive charts will be really good. So it would be opening up in a browser where the user has control to zoom in, zoom out, as well as maybe to download the image of the particular chart and so on. So these are all the concepts that will be covered over the next 3 days. I hope you will enjoy. Now let's go into the details, and let's start with Matplot library. Let's get into the tutorial and see how to plot a simple chart using Matplot library. We will be slowly getting into the details of how to give the axis name as well as title to a particular chart, how to make few adjustments to the charts to make it look better, like adjusting the size of the particular chart to fit all the data. So let's get into the details. The first one that is required in order to use visualization or in order to plot charts using Matplot library is we need to import the particular library. So as you see on my screen, we need to import Matplot library .pyplot as plot. So we will be using PLT in all of our codes in order to call this particular package. And we are also importing NumPy because some of the numeric data would be handled better as NumPy. And just in case, we will also import pandas, because the data that we are going to read will be a data frame which would require pandas library. So let's import all these packages. So as explained in the introduction, the Matplot library is really important. So even if you are going to use Seaborn later for your analysis, what happens is Seaborn is built on top of Matplot library. So the Matplot library is kind of like the basics that should be required to be learned by all data scientists to understand the concepts of how the charts are being built. And later on, you can keep adding more knowledge to your base. You can learn about Seaborn, which is especially very useful when you are doing exploratory data analysis, which needs to be really quick. You don't have time to writing lots of codes or making the chart look beautiful. So Seaborn would come with the default template, which would be better, and the default charts itself will be well represented, so it doesn't require any adjustments. Here in case of Matplot library, it does require some lines of codes. You need to define, like you need to it requires a line of code for every single change that you want to do to the default chart, as well as it is highly customizable. Like even though it requires lots of lines of code, but with those lines of code it becomes highly customizable. You can pretty much do whatever you want to a particular chart. So let's go into the details and see what can be done using Matplot library. So now we have imported all the required packages. So just before you start, if in case you don't have Matplot library, you can install it directly in the Jupyter Notebook, but I would say it is preferable to not install in the Jupyter Notebook, whereas to install from the command prompt, because like it would always be safe. And if you always use a command prompt to install all your packages, like it will be it would be better. Like there won't be any conflict or any issues. So moving on to plotting a simple chart. So what we are going to do is the first thing that is important while building a particular chart is we need to create a feeder, as well as we need to create subplot, like where we can actually draw these charts. So this is pretty much like it would be required in most of the plots that we are going to do. So it creates a particular feeder and it creates the subplot which would actually draw the chart for us and print it on the feeder. So when I execute this, like what's happening is here it's just it's a simple data, like it has two array. So let me execute and then show you the pattern. So as you see, what's happening is it has like a data for two axes, and based on like what we have given here, what's happening is the Matplot library is plotting a line chart based on the data that we have provided. So one axis it has up to 10, like this is the first axis, it has up to 10, 0 to 10, and the second axis, the axis 8. So this becomes the y axis and this becomes the x axis, and based on the patterns, like a line chart is being drawn here. So now so this is a simple line chart. Like we are not defining the name for the x-axis or the y-axis, or we are not giving a title for this chart. So what we are doing is we are just creating a particular feeder and as well as a subplot, and to the subplot, like we are passing on the data that needs to be printed. So now what happens is, like let's say we want to do a trend chart, like there is multiple line charts in one particular chart. So a trend chart is required, like multi-trend chart is required in order to find relationship between two variables, how their patterns are with respect to each other. So in that particular case, what's happening is again we will create a particular feeder and subplot. So here to the subplot, what we are doing is initially we are passing a particular list of elements that needs to be printed, and then we pass on a label to it saying that it is data 1, and we use the same subplot and then pass the additional data to it. So this will be the second trend. This is data 2. So what we are doing is so let's just print this and then see what's happening. So when I execute it, so as you see, what's happening is what we have done is we have added like another stream of input data to the same subplot AX, and we are able to see two trend charts together in a particular feeder. So let's say we want to give name to the axis. So what can be done is so by using this command like a set x label, we can pass on the name to the x-axis, and the set y label pass on the value or name to the y-axis. So by executing along with these lines of code, we can see that there has been a name created for both the axis, and for title we can use ax dot. So we are using the subplot for which the labels names should be set. So here in this case it's just one subplot. So the one variable ax, and then we pass on all the attributes, all the data points, as well as the names of the columns and so on for this particular chart. So when I execute along with the title, what happens is it includes the title for this chart as well. So that's about like so that's what is required for us in order to make a simple line chart or multi-trend chart. All we require is the data set. So we require the x-axis as well as y-axis, So in this case, like since we are the plots are on a same feeder, the x-axis is exactly same, and the y-axis, the other axis is slightly different, like because we are going to use, so it is like two different attributes we have chosen. So for those two different attributes on same axis or same dimension, we are seeing there, we are plotting that in order to see whether there is any relationship or whether there is any trend that is visible to our eye. So that's why we plot multiple variables together in a chart to see whether there is any pattern to it, like when one value increases, what happens to the other value. So this is kind of like a correlation test. So where instead of creating a correlation test as a black box, so we are trying to see the pattern in the data, and we are trying to see if there is something that is coming out. So the next one is, what we are going to do is we are going to see all these charts for a real data. So what I'm doing is I'm using an Netflix data. So this data set is available in this particular location. I will be sharing these locations as well, like maybe in the summary, or it should be available in the GitHub repository where I upload all these codes. So I'm using this particular Netflix data, and so this is stored in a particular folder, like located in my system. So in order to show you like what the data looks like, so this is how the data is looking like. It includes the show ID type, whether it is a movie or it is a TV show, and the title of the movie or TV show, the director, cast, country, date when it was added. The release year says that when this particular movie or TV show was released, and it also includes few other parameters like what is the rating, as well as the duration and a few other details. So what we are going to do is we are going to use this particular data. So in order to learn about these charts, I'm going to slightly modify the data to suit better to all our visualization use cases, and then we are going to see each one of them in detail. So next, what I'm going to do is I'm going to execute this where I am creating a subset. So for based on the release year, for all the movies as well as TV shows, I'm going to get the count of number of. So this is the complete database of movies and TV shows that is coming up in Netflix. I'm not sure which country this data belongs to, because the number of movies as well as TV show differs from one country to other country in Netflix. So I'm not sure about like which country this belongs to, or whether this data set is complete. So for now, what we will do is we will assume that this is a complete data set, and I'm going to get the details of various number of movies as well as TV show based on the release year. So this is how the data is now. So in order to make the plot using Matplot library, what I'm going to do is I'm going to pivot this particular column that you see here, which is the type, which says like how movies as well as TV show. What I'm going to do is I'm going to create movies as well as TV show as columns here, and the count of the movies as well as TV show will be represented under them. So this will be this 3 lines of code will be used for that. And what I'm going to do is whenever there is no data for a particular year, I'm going to, instead of printing them as not a number, I'm going to replace them with 0, because there is no movie for that particular year, or like no TV shows. So when I execute this, so this is how the data would look like. So for each year of release, how many movies as well as how many TV shows. So this will be for the complete data set. So let's use this for to learn about more about visualization. So now this has the release year, number of movies as well as number of TV shows per release year. So then what I'm going to do is I'm going to use pretty much the same thing. So I'm going to create a feeder as well as a subplot using this particular line of code, and then I'm going to pass on the data. So here what you can see is as specified previously. So previously we used to send we used to pass 2 arrays as input. So this one as well as here. So now here in this case with the actual data, what I'm going to do is I'm going to pass on the release here. So this release here will be the x-axis, which will be common, and the y-axis would be the number of movies as well as the number of TV shows. And I'm also passing a label. So in order to know which one is movies as well as which one is TV shows. So and I'm also setting the x-axis label and passing on the y-axis label as well as title. And let's print this and then see how the chart looks like. So as you see here, so this helps us in order in understanding that what's happening. So there are not much movies, maybe up to 2010. So like most of this database, this Netflix movie database has movies and TV shows predominantly after 2010, or maybe like it starts from 2000. Like before 2000, like I think there are very few movies and TV shows are present. So now to this particular chart, we can make some more customization or some more changes. Let's say this particular chart is now too small, kind of like very skewed. So let's say we want to make it much more bigger. So what we can use is we can define what should be the size of this figure that on which we are going to plot the chart. So so this is the figure that we have created here in order to make this plot. So I'm going to set size in inches, and then I'm going to pass on like how big this particular chart should be. So now let me execute this one. So now as you see here, it looks much more better. So it's much more bigger. It utilizes the whole space that is present here instead of compressing the chart into a small corner. So now we can see the whole chart like much more bigger, much clearer, like how the trend is. So now let's say we want to pass some comment and print it on the chart, because like when we are going to show this to maybe to a business user or to any stakeholders along with this particular chart, let's say we want to print some message and then tell them like what's happening. So what I'm going to do is I'm going to pass on a text that needs to be printed. So I'm going to say like a plot.text, and then what I'm saying is I'm passing on the location exactly where this needs to be printed, and this is the message that needs to be printed. So let me execute this one. So when I execute this as specified in the specified location, I can see the text that we specified is coming up in this chart. So this is how the chart would look like. So we have created the name for the y-axis, x-axis, and then we are able to print something into the chart. We are able to define like how big and small the chart should be. So depending upon the data, and then if it is too cluttered, we can make it much more bigger to make it more clear. So this is how an multi-trend chart would be actually plotted in a real use case. So as you see, the Matplot library, it includes multiple lines of code, like each and every, like in order to include the labels, titles, it is not picking up the actual name of their columns. For example, these axes would be available in the data as such, like the release year, movie, TV shows, but the Matplot library is not able to pick up the header of those attributes, whereas it requires us to pass on these values explicitly. So it does require like few lines of code. We have to pass on each and every single value. We have to pass on the size of the figure that on which the plot is being printed. By default, it would be very small, and then generally the data set that we worked on would be slightly bigger. Like it would have a lot of data. So it requires us to change those sizes, do some changes to it. And then the next one is like, let's see how to do a scatter plot. So again, it's same, like we are creating a figure. So this time I'm renaming the figure because like so that there shouldn't be any conflict, because we are going to set the size slightly different. We are going to pass on few other parameters which would be different from this figure. So I'm going to create a new figure, a new subplot, as well as I'm going to pass on the values that needs to be printed. So here in previously what we are doing is we are saying that ax.plot, like we are just defining that it needs to be a plot and then passing the values. So now what we are saying is we know that we are going to print and scatter plot. So we are saying plot.scatter, and we are plotting a scatter plot between like movies as well as TV shows. So before let me comment this and then start with the basic one. So we are saying that there needs to be a scatter plot between the attribute movies as well as TV show. So the scatter plot helps us to bring out some of the relationship between the attributes, like whether it is highly whether like it has any impact, like how how increase in one attribute, very similar to line chart, but this will be more intuitive. Maybe when I execute it, let me execute and show you how it is. So as you see here, what's happening is we are plotting the number of TV shows in a given year as well as the number of movies in a given year, and then seeing like if there is any relationship between them. So as you see here, in any given year, the number of movies as well as the number of TV shows are mostly consistent. there are a few outliers here and there where we can see that there are certain year where the number of movies is here is like 400, whereas yeah, it's 450. Not much of a difference. I think there is a lot of points here because the data set is quite big. So this is plotted based on the release year. So it is understandable that the data set has quite a lot of data. So it starts with maybe 1920s and it doesn't have much data until maybe 2000. So we can see there is lots of data like towards 0 or 1. And as we come to the most recent times, like maybe since maybe 2000 and after, we can see the scatter plot comes out from the shell, and then there is some variety in the data set. So that's how the scatter plot would look like. Let's say we want to give a specific color to the scatter plot. We want to change the default color. So what we can do is we can make use of this line here. We can say what needs to be the color. We can pass on the color of the points. So when I execute this, we can see that the points color changes. We can also change the font size here. So we can set for this particular plot what should be the font size. So by executing with this one, the font size also gets adjusted as per the value that we are giving. So these are all some of the additional customization that can be done to a particular chart. So the final one for today is about dual axis. So in this line chart that we have here, so what we are doing is we are printing the number of movies as well as number of TV shows. So we can clearly see that the number of movies, which is blue line, is a lot bigger, especially for the recent times, whereas there is not as much TV shows as compared to number of movies. So in this case, it is still fine, like it is still comparable. Like in some cases, what happens is one variable would be like the values of one variable will be very high as compared to other variable. Like maybe like one variable is in millions and the other variables in few thousands. But that could be an actual relationship between these two variables. So when we try to plot it on same axis, what happens is we won't be able to get the relationship between them because one is in millions and other is in thousands. So the one that is in thousands would be like a line which is close to the bottom. We can't make out any trend in or relationship with that of the other variable whose values is in millions. So in order to make them comparable, what we do is we use dual axis. So let me execute and then show you the advantage of dual axis. So what happens is when I use dual axis, like both of them will be scaled to same. For example, here the number of movies starts with 0 and then goes up to 700, and we are using the other side as for the other axis, which is to print number of TV shows. So this is number of TV shows. Even though the max is less than 500, it is scaled in order to make sure that we are able to compare it with that of the number of movies. So now what would happen is when we have two variables and one variable is just in thousands or in hundreds and the other variable is in millions, we would be able to plot them in the same chart by scaling the one that is very small to match the bigger one, and we should be able to get the relationship whether any increase in number of TV shows has an impact to the number of movies. So that's how like having a dual axis would be really helpful. Whenever the scale is like too much difference in the scale, we want to match it and then we want to see the pattern. So that's about it for today. So what we have covered today is we started with a simple line chart, like just using the raw data, how to plot a line chart, and we have seen like how to make use of a real data, how to convert it into a required format, like mostly using group by and aggregations, and how we can use this real data and make some plots. We have also seen how to give name to the axis, how to give a title to it, how to scale a particular figure on which the plot is being printed, as well as how to change the color or change the size of the text and so on, how to print a particular text in a location. So these are all like some important concepts that would be really useful when you are going to implement a visualization for a particular data. So visualization on any project is like very important because so this defines how the communication will be to the stakeholders. So what you want to convey to the stakeholders, like it depends upon how good your visualizations are. and one good visualization can beat like maybe any lines of paragraphs, or like maybe 15 minutes of a lecture too. So a good visualization would be able to clearly communicate all the details of the particular chart, or of whatever we are trying to convey to the stakeholders. So that's it for today. So tomorrow we will go into the details and see a few more additional charts on how to print them. So let's catch up today. So if you have learned something new today, and if you find this interesting, please give a thumbs up and subscribe to this channel. If you think that this would be useful for any of your friends, please feel free to share it with them. And yep, bye for now. See you on the next day. Bye.